Within our solar system, a realm that seems to have been thoroughly mapped after centuries of observation, there may still exist a planet that has never been seen. A mysterious world lying at the darkest and most distant edge, so far from Earth that conventional telescopes are unable to detect it directly. Scientists refer to it by a provisional yet evocative name, Planet 9. According to modern astronomical models and studies published over the past decade, Planet 9 is believed to be a solid celestial body composed primarily of ice and rock, similar to the super-Earths discovered around other stars. Its size may be at least twice that of Earth, with an estimated mass 5 to 6 times greater, sufficient to generate a powerful gravitational field that quietly influences the entire outer region of the solar system.
The planet's hypothetical orbit lies far beyond that of Neptune and even Pluto. At its most distant point, it may reach a distance equivalent to about 500 times the distance between Earth and the Sun. Not only is it distant, but Planet 9's orbit is also highly unusual. It is tilted by approximately 16 degrees relative to the common orbital plane of the other planets, a rare feature within the architecture of the solar system. The time required for it to complete a single orbit around the Sun may extend to 10,000 to 15,000 years, meaning that throughout the entire history of humankind, this planet has not completed even one full orbital cycle.
At such a distance, even a very large celestial body would be nearly invisible. The sunlight reflected from its surface is far too weak, causing it to fade into the darkness of deep space. This compels us to acknowledge a sobering reality. Humanity once believed it had a clear understanding of the solar system. Yet in truth, we have only begun to touch the surface of a far more complex structure. So, if Planet 9 cannot be seen, how do scientists believe it exists? The answer lies in a method that has repeatedly proven its accuracy throughout the history of astronomy: inference from gravitational perturbations.
This story begins with Uranus, the 7th planet from the Sun. In 1781, the British astronomer William Herschel discovered it using a homemade telescope set up in his own backyard. Interestingly, Herschel was not searching for a new planet at all. He was hunting for comets, and at first he himself believed this object to be an unusual comet. Only after observing its motion over a long period did Herschel realize that it was in fact a true planet, far larger than any comet. In reality, Herschel was not the first person to see Uranus. The planet had appeared faintly on star charts for many decades prior. However, because of its dim light and extremely slow movement across the sky, no one recognized it as a planet. As astronomers continued to monitor the orbit of Uranus, they discovered something troubling. Its motion did not fully conform to the precise predictions of Newton's laws. Along certain segments of its orbit, Uranus appeared to speed up or slow down in an unusual way, as if it were being tugged by an invisible force. This phenomenon is known as gravitational perturbation,
a sign that another sufficiently massive object is exerting an influence from a distance. By 1846, two astronomers, Urbain Le Verrier in France and John Couch Adams in England, independently arrived at the same conclusion. Relying entirely on mathematics and orbital mechanics, they determined that an undiscovered planet must exist beyond Uranus, and that this planet was the cause of the observed perturbations. Not stopping at theory alone, Le Verrier went on to calculate the precise position of this mysterious planet in the sky. In Germany, the astronomer Johann Gottfried Galle pointed his telescope exactly toward the predicted location. The result was astonishing. Within just a few hours of observation, he discovered Neptune, the 8th planet of the solar system. This is regarded as one of the greatest triumphs of theoretical science in human history. When mathematics saw a planet before the telescope did. After this success, the scientific community began to believe that analyzing gravitational perturbations was the key to discovering unknown worlds. As they continued to study the motion of Neptune, small discrepancies once again appeared. Its orbit seemed not to be entirely stable. This led to the hypothesis of an even more distant celestial body. The search continued until 1930, when the astronomer Clyde Tombaugh discovered Pluto, which at the time was considered the 9th planet of the solar system. Although Pluto was later reclassified as a dwarf planet, this story left behind an important scientific legacy. To understand why the search for Planet 9 is so difficult, we need to introduce a key concept in observational science: observational bias. This is a phenomenon in which the data we collect are influenced by the limitations of our instruments, measurement methods, or even human expectations, leading to conclusions that appear reasonable but do not accurately reflect the underlying reality. In the early 20th century, astronomers believed they were searching for a large planet beyond Neptune. When a new object was discovered, it was quickly assigned the role of the perturbing planet. But that object, as we now know, was Pluto, and that conclusion was incorrect. The reason lies in the physical characteristics of Pluto. Its surface has a very high reflectivity, covered with large amounts of methane and nitrogen ice, making it appear much brighter and larger than its true size when observed through a telescope. In reality, Pluto is far too small. Its mass is only about 0.2% that of Earth.
completely insufficient to produce any significant gravitational effect on Neptune's orbit. Later, when orbital measurements were refined using more precise data from spacecraft and radar technology, scientists realized that Neptune was not wobbling at all. All of the previously reported perturbations were simply measurement errors. However, this confusion did not put an end to the search for unknown planets. It simply imposed a new requirement. Astronomers had to be more cautious, more precise, and rely more heavily on statistics, simulations, and long-term data. And it is here that the modern story of Planet 9 truly begins. Over the past 3 decades, ground-based and space telescopes have opened up an entirely new view of the distant reaches of the solar system, a region known as the Kuiper Belt. This is the region of space beyond Neptune's orbit, where countless remnants from the formation of the solar system are concentrated. Pluto is just one of them. In fact, current models suggest that there may be thousands of objects comparable in size to Pluto. And farther out, tens to hundreds of billions of smaller objects with diameters of 1 kilometer or more. Most of them remain completely unknown because they are too small, too dark, and too distant to be easily detected. According to current hypotheses, if Planet 9 truly exists, its orbit lies far beyond the outer edge of the Kuiper Belt. At such a distance, we cannot realistically expect to see it directly. But a planet with a mass several times that of Earth would certainly leave traces. Not through light, but through gravity. And it was precisely these traces that drew the attention of 2 astronomers at the California Institute of Technology in 2016. Mike Brown and Konstantin Batygin. When analyzing the orbits of a small group of extremely distant trans-Neptunian objects, they noted something so unusual that it was difficult to attribute to chance. These objects were not distributed randomly, as would normally be expected. Instead, they were clustered together, with long, elongated orbits tilted in the same direction through space. The probability of such an arrangement occurring by chance is extremely low. It appears as though an invisible hand is shaping their orbits. As the number of discovered objects continued to grow, other strange phenomena gradually came to light. Some objects orbit the Sun at very steep inclinations, in some cases nearly perpendicular to the plane of the solar system. Others move in the opposite direction compared to most planets and asteroids. These orbits would be nearly impossible to remain stable without long-term influence from a powerful gravitational source located far away. Just as 19th century scientists once inferred the existence of Neptune, Brown and Batygin approached the problem through numerical simulations. They recreated the early solar system in computers,
at a time when the planets were still forming and the orbits were chaotic. They then ran two parallel scenarios. One scenario without Planet 9, and another with a large, distant planet on a highly inclined and very elongated orbit. The results were remarkably clear. In the scenario without Planet 9, the objects of the Kuiper Belt gradually dispersed randomly over time. But when Planet 9 was included in the simulation, the distant orbits naturally reorganized themselves, matching with striking accuracy what we observe today. According to their initial statistical analysis, the probability that these structures could arise without the presence of Planet 9 is only about 0.4%, corresponding to a 99.6% likelihood that a large planet is responsible for this effect. That figure is not absolute proof, but in planetary science, it represents an exceptionally strong signal. However, these simulations raise a deeper question. How could such a large planet appear in a region where planet formation should not be possible? The Kuiper Belt is far too sparse in material to form a large celestial body. This leads to two most plausible scenarios. The first scenario suggests that Planet 9 is a rogue planet, a celestial body that once belonged to another star system but was ejected by chaotic gravitational interactions within young stellar clusters. In a rare moment billions of years ago, the Sun's gravity may have captured this planet, trapping it in a very distant and highly inclined orbit. The second scenario proposes that Planet 9 originally formed much closer to the Sun, possibly in the region between Saturn and Neptune. During the early chaotic phase of the solar system, it was flung outward by the giant gas planets before it could accumulate enough gas to become a second Jupiter. The push was not strong enough to eject it entirely from the solar system, but sufficient to send it into the outer reaches, where it has remained trapped to this day. In both cases, Planet 9 is predicted to be an extremely cold, dark, and massive world. A sphere composed of rock, metal, and frozen material, resembling the exposed core of a planet that never had the chance to fully grow. If Pluto is already a dead and frozen world, then Planet 9 would be far more extreme. The paradox is that despite never having been seen, we are able to infer its mass, orbit, and even its possible origin in considerable detail. But the most important question still remains: where is it? Exactly where is it in the sky? And unfortunately, answering this question will be far more difficult than any planetary search undertaken previously in the history of astronomy. The greatest challenge in the search for Planet 9 lies in a very simple, yet extremely harsh reality. If it exists, it is extraordinarily distant and extraordinarily dark. According to current orbital models, Planet 9 could be more than 15 times farther away than Neptune. At that distance, sunlight would barely be enough to illuminate the surface of any object. Unlike the gas giant planets with highly reflective atmospheres, Planet 9 is predicted to be a cold, dense, and solid world, lacking a thick atmosphere rich in luminous methane or hydrogen. This makes it far less reflective, allowing it to blend almost completely into the absolute darkness of deep space. In that scenario, Planet 9 would be invisible to most telescopes, except for the largest and most sensitive instruments ever built on Earth. But even with the world's leading observatories, detecting it would still be like searching for a needle on the ocean floor, because the sky is vast and the planet moves exceedingly slowly. And it is precisely here that an unavoidable question arises. What if Planet 9 does not actually exist?
We have previously mentioned the concept of observational bias. In this case, two astronomers at the California Institute of Technology, Mike Brown and Konstantin Batygin, were actively searching for evidence of a large, distant planet. When you search for something very specific, the human mind and statistical models tend to interpret data in ways that reinforce the initial hypothesis. This does not mean they are wrong, but it opens the possibility that the observed phenomena may have alternative explanations.
And some alternative hypotheses are even far more radical. One of the most controversial scenarios is the idea that instead of a planet, the object causing the orbital perturbations could be a tiny black hole. Not the kind of black hole formed from the death of massive stars, but a primordial black hole. According to cosmological theory, these black holes may have formed shortly after the Big Bang, when the universe was extremely dense. Some of the densest regions of matter could have collapsed directly into black holes, completely bypassing the stage of star formation. If such primordial black holes exist, they could wander through the universe like invisible ghosts. In theory, it cannot be ruled out that the Sun may have captured a small black hole like this into a very distant orbit. Its gravitational pull, despite emitting no light, would still be sufficient to rearrange the orbits within the Kuiper Belt.
However, to date, there is no direct observational evidence confirming the existence of primordial black holes, either within the solar system or in the depths of the wider universe.
Another explanation, less sensational but no less profound, relates to the very nature of gravity itself. All of the orbital predictions we currently use are still based primarily on the laws formulated by Isaac Newton in the 17th century. But it is important to remember that Newton never observed any objects lying beyond the orbit of Saturn. It is entirely possible that at extremely large distances, gravity does not behave exactly as we are accustomed to.
In this scenario, the strange orbits of distant objects are not evidence of a hidden planet, but simply a manifestation of natural laws operating in ways we do not yet fully understand. The history of science has repeatedly shown that phenomena which initially appear anomalous often turn out to be clues, leading to deeper and more comprehensive theories.
Regardless of which scenario is correct, one thing has become clear. We have been overly confident in believing that we understand the solar system simply because we can observe the region of space near Earth so well. The farther we venture, the more we realize how limited our understanding still is.
But that is about to change.
This is the Vera C. Rubin Observatory, one of the most advanced astronomical facilities ever built on Earth. It houses the largest and highest resolution digital camera in history, designed to carry out an unprecedented mission, imaging the entire observable night sky repeatedly, every 3 days.
Vera Rubin began scientific operations in the summer of 2025. And over the course of 10 continuous years, it will survey the sky with an unprecedented level of depth and precision. The result will not merely be a collection of images, but a time-lapse movie of the universe, in which every moving object leaves a trace.
In this new era, we will no longer need to hunt individual targets one by one. New comets, interstellar objects, and near-Earth asteroids will all reveal themselves through their motion against the fixed background of stars.
And if Planet 9 truly exists, whether it is a dark, icy world or something even stranger, it will not be able to hide forever. This time, it will not be belief or speculation that determines the answer, but data. And very likely, within the next decade, this mystery that has persisted for more than 100 years will finally be brought into the light. Thank you for joining us on this journey to the farthest edges of the solar system.
If you found this video helpful and engaging, don't forget to hit like to support the channel, subscribe, and turn on notifications so you won't miss future videos exploring science, the universe, and mysteries yet to be revealed. Your support is the driving force that allows us to continue exploring what lies beyond our sight, but never beyond human curiosity.